we are getting into the fascinating world of oxides. So to begin with, let's talk about Venus, our nearest neighbor in this solar system. So why am I talking about Venus? Yeah, Venus is identical in size and density to the Earth, but Venus is kind of veiled. It is veiled and life cannot exist there, and it is kind of a threat to the probes, the spacecrafts that are moving around. So why is this happening? So have you heard of the acidic clouds that are around? The atmosphere is filled with the acidic clouds in Venus. So if you see, Venus is covered in a thick toxic clouds of sulfuric acid, and they extend above the planet's surface. So the clouds are made up of sulfuric acid droplets, water, chlorine, and iron. And this sulfuric acid clouds of Venus are a product of great volcanic activity. So this has thrown out huge amounts of water vapor and the oxides of sulfur into the planet's atmosphere. So similar acidic clouds can actually be created in the lab. Wow, that's wonderful. When sulfur is burnt, okay, in the presence of oxygen, when you burn this, you get sulfur dioxide. And when you add water to this sulfur dioxide, remember, when you add water to the gas jars, it dissolves the gases and gives solution which turns blue litmus paper red. And in the previous sessions, we have learned that litmus paper is a test to, it tests the acidity or alkalinity. And remember the mnemonic, acid has a D, which is a part of red. Remember this? So the litmus paper turns red. Blue litmus paper turns red when it is an acid. So sulfur dioxide, when it kind of dissolves in water, it gives acidic solution. And this can be tested using a litmus paper. Other burning nonmetals, example, carbon. Okay, if you take carbon and if you're going to burn it, it's going to produce those acidic gases like carbon dioxide. You have carbon dioxide, which is produced when you burn carbon in the presence of oxygen. So when water is added to the gas jars, like, when water is added to carbon dioxide, it will give solutions that turn blue litmus paper red. Now, these acidic solution, now here, carbon dioxide actually becomes carbonic acid. It becomes carbonic acid. So carbon dioxide gas, when it is bubbled through water, carbonic acid is produced. So these gases, which are soluble, they are acidic. They are acidic. So this is, this reaction is separate. Remember, this reaction is separate, and this reaction is another reaction that goes on. But in general, all nonmetals, when they combine, when they are burnt, they give out a nonmetal oxide. And this oxide, this nonmetal oxide, when it is dissolved in water, it produces an acidic solution. So acidic oxides are oxides of nonmetals. So here you see sulfur is a nonmetal, carbon is a nonmetal, nitrogen is a nonmetal. So they are oxides of nonmetal that will react with bases and dissolve in water to produce acidic solutions. So these are acidic oxides. Now, burning metals, okay, let's look at this. So when you burn metals, they produce oxides that, if they dissolve, give solutions that turn blue, litmus paper blue. Now, think about it. It turns litmus paper blue. So what is the kind of solution that is made? So yes, So the metal oxides produced in this reaction, in these reactions, react with acids to neutralize them, and they are called basic oxides. Okay. So burning metals gives you metal oxides, and this, when you dissolve metal oxide in water, it will give out gases which will turn red litmus paper blue. So remember, these metal oxides are also called bases, and they are alkaline in nature, and because they are called bases, they are called basic oxides. They are called basic oxides. So basic oxides of a metal, they are oxides of a metal that will react with acid to neutralize that acid. So here are a few examples. So copper is a metal. When it burns, it becomes copper oxide. Now this copper oxide actually turns, when you dissolve this in water, it turns red litmus paper blue. And same way, aluminium, when it burns in oxygen, it forms aluminium oxide. So these are examples of basic oxide. So let's recap what we did just now. So metal plus oxygen gives you a metal oxide, and this is alkaline. So therefore, they are called basic oxides. When this, oxides dissolve in water, they turn red litmus paper blue. So these are called basic oxides. And these metal oxide, a few examples are copper oxide, aluminum oxide. And then when a non-metal is burnt, there is a non-metal oxide formed, and this, when dissolved in water, produces an acidic solution. So therefore, they are called acidic oxides. So a few examples are sulfur dioxide, carbon dioxide, nitrogen dioxide. And when they dissolve in water, they form acidic oxides. So that's why you get acid rain. When sulfur dioxide dissolves in water, there is acid rain that is produced. Okay, so let's learn this as a flow chart. So here you have a lot of oxides like carbon dioxide, sulfur dioxide, calcium oxide, and so on. So if you see the metal oxides that are here, they are also called basic oxides. So metal oxides are also called basic oxides because when they dissolve in water, they give an alkaline solution. They give an alkaline solution which has a pH greater than 7. And if you see non-metal oxides like carbon dioxide, sulfur dioxide, nitrogen dioxide, when they dissolve in water, they form acidic solutions. So here you see HNO, nitric acid, carbonic acid. So these are acidic solutions which have a pH less than 7. So this is a simple flow chart. This is a simple flow chart which will help you remember the metal oxides, which are basic oxides, and not metal oxides, which are acidic oxides. Okay, now let's talk about neutral and amphoteric oxides. So which is a neutral oxide? So naturally it should have a pH of 7, a neutral pH. So what do you think is a neutral oxide? So water can be thought as hydrogen oxide. We can, because it's H2O, right? It's H2O. So we can think that it is hydrogen oxide. And it has a pH of 7, and it is therefore a neutral oxide. It is an exception to the broad rule that the oxides of nonmetals are acidic oxides. Although water is a nonmetal, it is not an acidic oxide. It is a neutral oxide. And neutral oxides do not react. Okay? No reaction. They do not react with acids or with bases. I hope that is clear. So they do not react with acids or bases. Carbon monoxide is a neutral oxide. Talking about amphoteric oxides, there are lots and lots of metal oxides, and most of the metal oxides are basic oxides. Usual behavior of some metal oxides. There are few metal oxides which have an unusual behavior. Now, these metal oxides, they react with they react with acids. They react with acids. They also react with bases. They can neutralize both alkalis, reacting acids, which is unusual. So these, they can react with acids and neutralize them. They can react with bases also. So such metal oxides that can react either with an acid or a base to produce salt and water are called amphoteric compounds. I hope this is clear. These are called amphoteric compounds. So we saw that neutral oxides, they do not react with acids or bases. But amphoteric compounds, they react with both acids and bases. So amphoteric compounds neutralize both acidic and basic substances. Okay, the most important examples of metals that have amphoteric compounds are zinc and aluminum. There are lots, actually, many metalloids and metals. But then for IGCSE, you need to kind of know that zinc and aluminum, they are amphoteric compounds. So zinc oxide and aluminum oxide both react with acids to produce the expected salt and water. Now, for example, if you take zinc oxide, okay, it's a solid. Remember to write the state symbol. When it reacts with an acid, take HCl, and remember acids, they have to be in aqueous. Okay, acids cannot be, they have to be in solution. So what does it give? Now remember, they neutralize. So when acid and base, when they neutralize, now what is a general equation? I think you know the general equation. When an acid reacts with a base, what does it give? It gives salt and water. So remember, so here you have this compound, zinc oxide. Now it is kind of reacting with a HCl. So it acts like a base and it's going to give us salt and water. So let's say water. Let's take out water first. So what is the kind of salt that is going to be made? So H and O are gone. So it should be zinc chloride. Zinc chloride. Make sure to balance the equation. It should never be unbalanced. So here you have zinc, which is 1. Here zinc is 1. Oxygen is 1 and oxygen is 1. Hydrogen is 1 and hydrogen is 2 here. So you need to make the reactant side also equal to the product. So let's add a 2 here. And chlorine, yeah, chloride has become 2 and chlorine. So yes, so this is a balanced equation, and you have to add the state symbol. Salt is in aqueous and water is liquid. So this is the equation for this amphoteric compound when it reacts with an acid. Okay. Now, however, they also react with an alkali to produce salt and water. So let's take an example. Let's react zinc oxide, which is a solid, with sodium hydroxide. Let's react it with sodium hydroxide. So sodium hydroxide should be aqueous. Remember, the acids and alkalis, they cannot be solid. They have to be aqueous. So remember water. Okay, let's take out water first. So what is remaining? So here in this case, it is sodium zincate, which is Na2ZnO2. Make sure to balance it. So there is Zn is 1, Zn is 1, oxygen is 1, oxygen is 1. Here oxygen, it's 2. And here there are 3 atoms of oxygen. here there is one atom of sodium and there is two here. So let's balance sodium first. So let's make this 2. So now we have 2 plus 1, 3 atoms of oxygen and 3 atoms of oxygen. So this balances the equation. So this is sodium zincate. This is sodium zincate. Okay. So this is how, an amphoteric compound reacts. It neutralizes an acid and it also neutralizes an alkali. So this is about amphoteric compounds. Now, what I want you all to do is try out the next amphoteric compound, which is aluminium oxide. So try out aluminium oxide. So I've made a flow chart for you, which divides oxides into 4: acidic oxides, basic oxides, amphoteric oxide, and neutral oxides. So if you see, the acidic oxides are all the non-metal oxides. When they react, when they dissolve in water, they form acidic solution, and they can react with alkalis to form salts and water. Now, basic oxides, all the metals, they are basic oxides, and when they dissolve in water, they form alkaline solutions. So they react with acids to form salts and water. So if you see, what are amphoteric oxides? They are oxides, some metal, some of them are metals, some of them are metalloids. They react with both acids and alkalis. They neutralize both acids and alkalis to form salts and water. And neutral oxide is our hydrogen oxide, which is our lovely water. And there are some exceptions like carbon monoxide, nitrous oxide. These neutral oxides, they do not react with both alkalis and acids. Now pause the video, read the question that is given below, and try to answer on your own. So the question is, define the term amphoteric oxide. So remember, define is a state. It's a command word which wherein you need to answer it as a definition. So an amphoteric oxide is one that will neutralize both an acid and an alkali to give salt and water only. Now they're asking you to write a balanced equation for the reaction of aluminium oxide with hydrochloric acid and sodium hydroxide. So I had asked you to do this before. Hopefully you have done it. So here you go. Aluminium oxide, when it reacts with hydrochloric acid, it gives you AlCl3, aluminium chloride and water. Now an easy way to get the formula of aluminium chloride. So what is the valency of aluminium? It's 3 plus. And what's the valency of chlorine? It's -1. So -1. So remember, whenever you have to get the formula, you just need to swap the valencies. Now these are the valencies. And how will you get your valency? You will have to check your periodic table. So you just need to swap them. You need to swap them, swap the valencies. So here you get AlCl3. So that's how you've got this formula. So water, so a salt is formed plus water. Now, aluminium oxide with sodium hydroxide will give you sodium aluminate. This is sodium aluminate and water. Now go for the next question. Try to answer it on your own. Pause the video and answer it on your own. So name one amphoteric metal hydroxide and write the word and symbol equation for its reaction with sodium hydroxide solution. So they are asking you for a metal hydroxide. So therefore, you can either choose zinc hydroxide or you can choose aluminum hydroxide. And then you have to react it with sodium hydroxide. So watch the information. The information given is very important. So zinc hydroxide or aluminum hydroxide can be chosen. And then when it reacts with sodium hydroxide, what does it give? It gives sodium zincate. This is called sodium zincate, and this is called sodium aluminate. Remember, the salts that are produced, that are formed in the reaction with sodium hydroxide, they are soluble and they contain compound ions with names ending in ate. So that's why, this is sodium zincate. This is sodium zincate, and this is sodium aluminate. No, because they contain oxygen, the name gets turned to zincate. The fact that zinc hydroxide and aluminum hydroxide are also amphoteric helps in the identification of salts of these metals using sodium hydroxide. So this is done in chemical analysis. So when you come to chemical analysis, you will see the importance of this. So remember, so zinc hydroxide, aluminum hydroxide, both are amphoteric. Okay. All right, guys, that's a wrap on oxides. I hope you found this lesson as fascinating as I did. Don't forget to like, subscribe, and hit the notification bell so you never miss out on our chemistry adventures.